Hi everyone. Today in this video we are going to understand what is an API gateway in microservice architecture. To understand it in better way, we first need to know why it is needed in microservice architecture at the first place. Just imagine if we had not used the API gateway, what would our application be like? Like in every microservice architecture, we are dealing with number of microservices. If we had not used the API gateway, then every service has to make a direct call to every other service. Every microservice has to maintain a metadata information like network IP address, port number, version, application name, health check URL. All these details each and every microservice has to maintain to make a communication. Next, like every microservice has to take care of routing part. Based on the URL path, it has to decide what next service the request should route to. It has to take care of security part. It has to validate the user credentials, and if the user is not authenticated, it should show the proper unauthorized error message. And if the user is authenticated with valid credentials, it should authenticate the user, and it should also check for the authorization part of the user, like it has to take like whether user has enough permission to access the protected resource of the target microservice or not. So all these details each and every microservice has to take care of. So these are some notable features, but there are many more features or points each and every microservice has to take care of if we had not used API gateway in our application or architecture. Knowing all these points and implication of all these points, still if we have decided to implement all these cross-cutting concerns and points in each and every microservice, then what would happen? Obviously, our architecture will become more complex and will become unmanageable, and moreover, like we will lose the essence of the microservice, and we will not get the core benefits of what the microservice is designed for. Now let us understand our main point, that is what is an API gateway. API gateway is a server that sits between the client and a collection of microservices and acts as a single entry point for all the client requests. It will route the client request to the appropriate service and then return the response back to the client microservice. Now let us understand how API gateway works. As we know that in real practice we are dealing with number of microservices, each one is having its own database, and the requests may come from a client or mobile, or it can come from web or some client microservice as well. All these incoming requests will first go to API gateway. Next, like API gateway will further contact with the authorization server. If the request is new, then it will validate the user credentials and it will authenticate the user and send the response back with the proper status to the API gateway. It will also check for the authorization part, like if the user has valid or enough permissions to access the protected resource of the target microservice or not. So in that way, like authorization service will check for the authentication and authorization part and send the proper response back to the API gateway on successful authentication and authorization. If the request is carrying the JWT token in request headers, whether it's a JWT token or any other token, if it is carrying the token in header of the request, then authorization server will also validate that JWT token to check like whether that token is valid or not. Further, the API gateway will query the service discovery to get the network IP address and port number of the target microservice based on the URL path. Service discovery will send the response back with available list of microservice instances, and it will send all the network IP addresses and port number of the target microservice instances. Now the API gateway has number of instances available to choose from. The API gateway will use round robin load balancer strategy to choose a particular network IP address and port number of the target microservice and route the request to the target microservice. Now let's say API gateway has sent the request, route the request to the product microservice instance. Now the product service will further process the request data and send the response back to the API gateway. This is how the API gateway will send the request to route the request to every other microservice and get the response back from them. Finally, the API gateway will send the response back to the calling client microservice. This is how the API gateway will work, and the request will flow from calling microservice to the API gateway to the target microservice, and target microservice will send the response back to the API gateway to the calling client microservice. What are the important features of the API gateway? Like, API gateway will help to authenticate and authorize the user. Like, the API gateway will contact with the authorization server or some dedicated microservice which will validate the user credentials and authenticate the user, and it will also help us to authorize the user. Like, it will check if the user has enough permission to call the protected resource of the target microservice, and it will also decouple the authentication and authorization from all the microservices. Next is a request routing. Like, based on the URL path, it will determine what next service to call and route request to appropriate microservice. Next is aggregation. Like, open a single client service may require data from multiple microservices. So instead of client having to make multiple calls to various services, the API gateway can aggregate the result from multiple services and return a single consolidated response back to the client. So this will help to reduce the number of requests the client need to make. Next is a protocol translation. Like, it will help to translate between protocols like HTTP to WebSockets and gRPC, etc. This will enable different microservices to use different communication protocols. Load balancing. Like, the API gateway can distribute incoming requests to multiple instances of the microservices. This will help to ensure that the load is evenly spread across the service instances, improving availability and scalability. For example, if there are 3 instances of a product service, the API gateway might use a round-robin algorithm to choose which instance to send the request to. Next is a rate limiting and throttling. Like, the API gateway can impose rate limits to protect services from being overwhelmed by too many requests. Like, it can control how open a client can call the API within a certain time frame or time period. For example, let's say 100 requests per minute it can set. This will basically prevent service degradation or outages. Request and response transformation. It will modify the request. It will help to modify the request before forwarding or the response before returning to the client. This is basically useful for API versioning and masking sensitive data. Next is a composition. If we want to present different views based on whether the request is coming from mobile or desktop. So if we want to present 3 views if the request is coming from mobile, and 5 views if it is coming from a desktop device, in that case we may call 5 microservices if it is coming from desktop device, or 3 microservices we can call if it is coming from mobile device. That kind of logic or combination is possible with the help of composition. Next is a caching. Like, to improve the performance, an API gateway can cache responses from various microservices and return them directly to the clients without forwarding the request to the backend service again. So this reduces load on backend services and improves response time for repeated requests. Next is a logging and monitoring. Like, it will help to log requests, responses, errors, and also helps in debugging, performance tuning, and monitoring usage patterns. Next is a support for API versioning. Like, it will allow different versions of API to coexist. Like, we can create a service with old or new API versions and enable safe transitions when uploading services. Finally, it's a security features. Like, it supports TLS termination and can integrate web application firewall for threat protection. So this is all the important features of the API gateway. Now let us understand how API gateway handle massive traffic load. If we understand this point, that means we have really understood how API gateway behaves in a situation when the massive traffic load comes in. Now let us understand how it handles such a situation. First, the client will make a request to the microservice. That request will come to the API gateway. API gateway will further decide based on the URL path to which load balancer this request should route to. Now let's suppose like API gateway has routed the request to the load balancer 1. Now the load balancer will further route the request to the particular running instance of the microservice. Let's suppose that load balancer 1 has routed the request to the product service instance which is running. As the load increases, the load balancer will keep on creating the multiple instances of the product service to cater the incoming request flow. Now, one thing we should note that load balancer will not make a decision based on the URL path which microservice to call. Rather, it will only evenly distribute the incoming request flow to the number of service instances available of a particular microservice. Now, this point is very important, which will differ the load balancer from the API gateway functionality. In a similar fashion, the load balancer will keep on sending the request flow to the rest of the services and keep on creating the number of instances to cater the incoming traffic load. Now let us think what would happen if any service instance get failed. So in that case, load balancer will create a new service instance to make up that space. Like it will create a new service instance and route the request to that newly created service. This way, it will evenly distribute the load to all the available microservice instances. Now, what would happen if the load balancer itself gets failed? Now, in that case, the API gateway will take care of that and reroute the request flow to the another load balancer which has similar kind of setup and the instances running in that load balancer. Now let us think if all the load balancer gets failed due to some reason, then what would happen? Like if this is the situation, that means all our whole availability zone gets failed. Now this situation need to be handled with a special care and a special way. Like in that case, like if our API gateway is integrated with the DNS system, then it can use the DNS based failover mechanism to reroute the traffic to healthy instances or the endpoints of the another availability zone. Now it will send the request flow to the another availability zone which has similar kind of setup and number of instances available. Now this way, if any availability zone gets failed, the API gateway will route the request flow to the another availability zone only if our API gateway is integrated with the DNS system. Now let us think beyond this, and if all our availability zone gets failed, if that is the case, that means our whole region gets failed. So that is the as a more picture, like it's a region failure, and we have to handle this in a special way. Like if the application in region 1 goes down due to some failure, let us assume that this is our region 1, and if the application in region 1 goes down due to some failure, then the API gateway in region 2 can take over and direct the traffic to the application instances running in that region 2. It's a simple, like if the region 1 gets failed due to some reason, then the API gateway will route the request to the to the another region which is available. Okay. Now let us think, like to even though it is looking a bit simple, but to implement it, it is like we need certain configuration failover mechanism, such as we can use the DNS failover with Route 53 which is available in AWS, or similar kind of services which are available in other cloud providers. Now this is how we have covered all the scenarios, like what would happen if any instance get failed, in case of the load balancer get failed, in case of the availability zone itself get failed, and finally we have seen what if the entire region gets failed, how it will tackle that situation as well. So this way API gateway will take care of every situation by being highly available and keeping all the instances running, and by being highly available to cater with incoming request flow, whether it is a small or whether it is a massive traffic, or there is a massive traffic, or there is a decrease in a load, whatever situation, it will cater with the incoming request flow by scaling up and scaling down the number of instances which are running. Now let us understand what are the examples of the popular gateways available, API gateways. Like we have Kong, Nginx, Spring Cloud Gateway, AWS API Gateway, and there is a Joule, Netflix. These are some of the popular API gateways which are available. I hope you must have enjoyed this. So please do not forget to like, subscribe and share, and thank you so much for watching this.